So, everybody, area of a full circle is, that circumference, area of a circle is pi r squared. Okay. So then, if we're only finding a section, area of a section of the circle, you'll say, but instead I don't want the area of the full circle, I want the section out of 360 times by pi r squared, right? Instead, so out of, since it's a central angle, we want 120 degrees worth of area. Out of the full circle, pi, and then 5 centimeters squared. So then what would the mathematician's answer be? No, the like a math person would want it in terms of pi. No, the math person would want it this answer, right? 25 pi thirds. Is everybody able to get that? And then it was square centimeters. Now, what would the engineer want? They'd actually want pi multiplied in. So how many approximate centimeters? Okay, so 26.8 square centimeters. Everybody good? Oh, 1/8? Okay, perfect. Right, so everybody, it makes sense of why the engineer would want this answer, and then this answer looks pretty because it's exact, not approximate. So us mathematicians. Anyways, okay, sweet. Moving on. Today we are getting into the nitty-gritty of the unit circle. Everybody listen. For me to teach this well, I really do have to be able to think. So make sure you're not talking when I'm teaching, because then all I'm thinking about is you talking. So we're going to be focusing on the unit circle. You learned this in secondary too. You got into the nitty-gritty of it. I'm hopefully going to just make sense of it. We're going to get right into it. I'll give you all of where everything comes from and whatnot. We'll just get right into it. And hopefully if it didn't make sense last year, it will this year. Here we go. So consider a circle. Just in general, guys, just a reminder, everybody up here. The equation of a circle is x minus h squared plus y minus k squared equals the radius squared. That is the equation of any circle. So if I have this equation of a circle, x squared plus y squared equals 1, then this would be a shift, no shift left and right, no shift up and down, so starting at the origin, and then r squared equals 1, so my radius would be 1. So if I went out a radius of 1 and drew a circle, there we have it. Does everybody see my circle? So now picture us zooming in, zooming in, zooming in. And boom, we're just zoomed in on that. Does everybody see it? This is what we're really looking at. We zoom in here. That's where our unit circle comes in. So our unit circle is just a circle with radius of 1 starting at the origin. So there it is zoomed in. So notice these points. This makes sense if we're zoomed in. This is over 1 up 0, over 0 up 1, negative 1 up 0, and this should be switched over 0 down 1, correct? Over this point, over 0 down 1. Now, instead of having the real number line spread out, imagine us taking and instead wrapping it around the unit circle. So it's taking and wrapping the real number line around this unit circle. Where if we were going this way, we're wrapping it around this way, that would be going counterclockwise, and that would create positive numbers. And if we wrap the real number line and we go backwards, that's going clockwise, that would be negative numbers. Everybody good with that? Okay. Okay, so as we look at this circle, this unit circle created by an equation, x squared plus y squared equals 1, as the real number line is wrapped around the unit circle, each real number will correspond to a certain x, y value. So everybody look. If I'm going up, starting here, if I go up to that point, that's a real number, and that's going to be some x comma y point on this circle. Everybody understand? Now that's also going to correspond to a positive angle if I go up x, y. Is everybody feeling good? That'll also correspond to a central angle theta. That point will correspond to that angle. So let's say now, instead, I go down and create a negative theta. Now there's another xy point, so that's an xy point, but won't that be over x and then down y? Right, so that'll be x comma negative y. So we're just going to be looking at a bunch of xy points on this unit circle here. All right, get these down. For xy points, that's what you need to understand. We're talking xy points. These are the trig definitions. So here are the 6 trig definitions. Right now, you're not going to know where they come from. Next, I'm going to show you why this is true. So if we have xy points on a unit circle, and we do, then our sine of theta, our sine of our angle will be our y value. So in xy, all we have to do, if I say find sine of 45 degrees, all you have to do is look at y, and that's your answer, the y value of your xy point. I'll explain why in a second. Cosine of theta will just be the x value of your xy point. So if I say find the cosine of 45 degrees, you'll go to 45 degrees and look at the x value. There's your exact answer. Tangent of theta will be y divided by x. So you'll take sine over cosine, or y divided by x. Then remember that cosecant is the reciprocal of sine. So cosecant theta will be 1 divided by y. Secant is the reciprocal of cosine. So secant of theta will be 1 over x. And cotangent of theta will be the reciprocal of tangent, which is x over y. Now I'm going to show you why that's true based on your knowledge of right triangle trig in just a second. So I'll let you get that down. So based on your knowledge of a right triangle, so we just talked about, here's our unit circle. We have a radius of 1. So if I go up here to this xy point, right up here, from here to here is a distance of 1, correct? Isn't that still a radius? Okay. Couple things to note. We just talked about how that xy point has created an angle theta. Now if I draw, so this is x comma y. So if I drop down this little dotted line and create a right triangle, then we have a right triangle with, here's our theta. From theta, this will be opposite, adjacent, and hypotenuse. Correct, everybody? Based on your knowledge of right triangle trig. Okay? So think about it, guys. If this is some xy point, then the distance from here to here will be x, correct? And then from here to here, that distance will be y, correct? X, y, does everybody understand? Okay, so based on your knowledge of right triangle trig, sine of theta is opposite over hypotenuse. Well, we know on a unit circle our hypotenuse is 1. So from theta, sine is opposite over hypotenuse. So from theta, won't it be y over 1? Right? So that's why our sine of theta will be y. Does everybody understand? So all you have to do is look at the, if we have a radius of 1, then all we have to do is focus in on that y value, and that is our answer. Pretty cool, right? So then cosine of theta is adjacent, which is x over hypotenuse, which is 1. So x over 1, that's why, because of our unit circle being radius of 1, all we have to do is say the cosine of theta is our x value. Then tangent of theta is opposite, so tangent is opposite over adjacent, which is y divided by x. So that's why tangent of theta is y over x. And then obviously the other three are just the reciprocals. Cosecant, secant, and cotangent are the reciprocals. So now think about it, guys. Based on our knowledge of right triangle trig, isn't theta always a positive acute angle? Are there other angles out there that we would want to find sine, cosine, and tangent of? Well, yeah. Can you really technically create I'm going to go off here and create a negative, for example, negative 45-degree angle in a right triangle? No, right? So the thing is with just basic right triangle trig, we're restricted to quadrant 1, positive angles, correct? So what the unit circle does is it takes and extends our definition of right triangle trig and allows us to find sine, cosine, and tangent of even angles that are negative. For example, isn't this negative theta? Yeah. Correct? So here is an xy point. Now we know that this is positive x and negative y. So now we know that sine of theta is y, correct? Yeah. So we could now we can find negative angles, sine, cosine, tangent of other negative angles. Does that make sense, everybody? So this would be possible now that we have the unit circle. Now also, can you have a right triangle with another 90 degrees? Not possible. Well, we need to be able to find sine, cosine, and tangent of 90-degree angles. So now we can actually do that because we've extended our definition of right triangle trig to the unit circle. So this is 90 degrees. So now we can find the sine, cosine, and tangent because we have xy points here. So do you see how that extends it? Also, if I created, let's say, this is 135 degrees, can you have a right triangle with something greater than 90? An angle greater than 90? No. But now with the unit circle, we're able to go to and have these angles that are larger than 90 and know the sine, cosine, and tangent. Does everybody understand? Okay, because these are definitely just still right triangles, but in other quadrants. Does that make sense now? So now we're extending our knowledge of right triangle trig to basically, yeah, well, still many angles. Negative angles, larger than 90, 90, and so on. Okay, so you don't need to write this down yet on your unit circle paper. You still don't need to write it down. What I want you to understand is the unit circle is showing commonly used angles. These values for x and y come from our special right triangles, and we're going to get into the gory details of this so you know where these things come from. So what I want you to get out of this is here's a unit circle. These are just commonly used angles. So here's 30 degrees. Does everybody see? Here's 45 degrees, here's 60 degrees. We have 30, 60, 90 special right triangles, correct? And we have 45, 45, 90 special triangles. So that's why these are considered our like special values. Now, can't I draw in a degree measure of 15 degrees? You could, but that's just going to be, these are on the unit circle are just the special ones that we use the most often. Does that make sense, everybody? Okay, so these are x, y points on our unit circle, and I'm going to show you where they come from. Are you ready? Where those values come from, algebraically. Here we go. So in a 45, let's say we start with the unit circle. I'm zoning in, I'm zooming in on this quadrant 1. Here we go. I'm going to create an angle of 45 degrees. Boom, there I am. Is everybody good? So we have an XY point here. Now I created a right triangle, so from that X, comma Y, I drop down and create a right triangle. Now we know this is 45 degrees, and this is a radius of 1, so right here is still a radius of 1. Is everybody comfortable with that? Now this is the relationship of 45, 45, 90 degree triangles. If you have a value and a value, then the hypotenuse will be the value square root of 2. So algebraically, let's pretend like we're not on the unit circle here, just back to right triangle trig. If this side's 7 and this side's 7, isn't it true to say 7 squared plus 7 squared equals the hypotenuse squared? So that's 49 plus 49 equals the hypotenuse squared. So that's 98 equals the hypotenuse squared. So solving for hypotenuse, we already know the answer, but I'm showing you algebraically why it is. We would square root both sides, right? We break that down. That's 49 times 2. 49 breaks down into 7 times 7. So we get 7 square roots of 2 equals hypotenuse. Everybody see how that's how I got my hypotenuse? Okay, so let's go through and algebraically, let's say we didn't know that xy point right there. Let's figure it out using algebra. So instead of saying that we know this xy point, I'm going to cross it out. We're going to pretend like we don't know. So what do we know? We have a 45 degree angle and a hypotenuse of 1. Everybody, I would do some algebra. In case I say show me why on the test, show me why the 45 degree angle is what it is. Here we go. So we know that this is 45 degrees and this is 1. Isn't that all we know so far? Now we know that this is some x value, correct? Right here is x. And this is y. Now, on a 45, 45, 90, isn't across from the 45 the same as across from the 45? So let's call x and y the same thing. So isn't it a true statement? So I'm going to call this x as well, because aren't they the same in this? So I'm choosing to just call y x again. Are we good? So isn't our true statement x squared plus x squared equals 1 squared? Yeah? Okay, so we have 2x squared equals 1. Solving for x, we would divide by 2. So we have x squared equals 1/2. Is that true? So then we would square root both sides. So we have x is equal to the square root of 1/2, which equals 1 over the square root of 2. That's my answer, but it's not an appropriate answer because we can't have a radical in the bottom. So we would rationalize the denominator. So our final answer for x would be the square root of 2 over 2. So isn't this also the square root of 2 over 2? So then, that distance from here to here was square root of 2 over 2, and this distance up was the square root of 2 over 2. So this x, y point must be the square root of 2 over 2, up the square root of 2 over 2. Everybody seeing how that works algebraically out? So that's where we got that point from, algebraically. Everybody good? So that's a point on the unit circle. Okay. Sweet. Any questions on where I got the 45 degree angle xy point from algebraically? Okay, let's go to a 30, 60, 90 special right triangle. So if this is what happens in a 30, 60, 90. So I'll just remind you of what happens because you should have got into the gory details of it last year. If you have a 30, 60, 90 degree triangle, this relationship will always be true. Whatever your hypotenuse is, across from the 30 will be half that amount. So do you see how this is 30 degrees? So this is length 30, so across from the 30 degrees will be half of the hypotenuse. So that's 15. Does everybody understand? Then if we went through the algebra, we would find that the other side will be 15 squared to 3. So it'll be the other side will be the 30 degrees, or the across from the 30 times by the square root of 3. Does everybody see the relationship? Okay, so let's look at our triangle on a unit circle. Since our hypotenuse is 1, let's pretend we don't know those x, y points. So if this is 1, then across from the 30 degrees will be half that amount. So right here will be 1/2. Now let's use algebra to find our x value. So we know that x squared plus 1/2 squared, x squared plus 1/2 squared equals our hypotenuse, which is 1 squared. So that means that x squared plus 1/4 equals 1. Solving for x squared equals 1 minus 1/4. X squared equals 3/4, right? Square root both sides. X is equal to the square root of 3 over the square root of 4, which is 2. So this distance will be square root of 3 over 2. So that's where this point comes from. That's distance over square root of 3 over square root of 3 square root of 3 over 2 up 1/2. So does everybody see where that xy point comes from algebraically? Yeah? And then also that's where this would come from because this is still a 30, 60, 90 right here, right? Everybody good with that? Okay, so that was just showing you where they come from. So in regular, we don't even get into that. We just say, here's the unit circle and memorize it because they don't care about y. But I know many of you, if I just said to you, here's the unit circle, here are the values, go for it, memorize it. You'd be like, well, where do those values come from? So now we know. Special right triangles. Everybody good? Okay. Now watch. I don't want you to fill in the unit circle yet, but watch how easy this literally is awesome. Like, watch how easy this unit circle makes us finding these values, these exact values. So everybody just watch. Remember that sine of theta will be our y value, cosine of an angle will be our x value, and tangent to y over x. So everybody watch. If I said to you find sine of 60 degrees, find the exact value, you would use the unit circle, go to 60 degrees. Sine is y, correct? So our answer would be the square root of 3 over 2. Our exact answer for the sine of 60 is square root of 3 over 2. Oh, I don't like that. Square root of 3 over 2. Now, wasn't that a lot easier than actually having to go through and do right triangle trig? I think it was. Okay, now let's do another one. So, the unit circle makes our life easier, not harder. Watch how much easier it is now. If I say to you, find cosine of 240 degrees, now you're not going to say that's not possible because you know that trig goes further than just right triangles. You'll locate 240 degrees. There it is. And cosine is x. So our answer is negative 1/2. There's our exact value for cosine of 240 degrees. So it says find tangent of negative 30 degrees. So you'll go to negative 30 degrees. Well, this is up 30. Now we're at negative 30. So we're looking at this value. This xy point tangent is y over x, correct? So our y value is negative 1/2 divided by square root of 3 over 2. So that's my answer, but if your answer is not simplified, you will simplify it. Dividing fractions is easy as pie. We flip the second one and multiply. So our answer is negative 1 over the square root of 3, correct? Still not an acceptable answer. We would then rationalize the denominator, square root of 3 over square root of 3, which is negative square root of 3 over 3. So that would have been our answer, which is pretty easy, right? Okay, awesome. So now I'm going to show you how I fill out the unit circle. There's going to be a quiz next time on being able to fill it out from scratch. I'm going to show you a trick. You don't have to memorize anything. This is literally pretty simple. Here's a trick I use. Now, your tricks might be different than my tricks. It's all okay. But let me just show you some ways I fill it out. I don't have it memorized to this day. I mean, to some extent. Okay, here we go. So the first thing I do when I give, now you would be filling out a blank unit circle. Like grab one off your desk. This is my trick. So your tricks might be different, but watch how easy. The first thing I do is fill in my XY points that are with zeros and ones. So isn't this over 1 up 0? This is over 0 up 1. This is negative 1 up 0. And this is over 0 down 1. Then from there, I go in and fill in my degree measures. So, a couple things we know for a fact. This is 0 or 360 degrees, correct? Everybody? Yeah. Then this will be 90 degrees, correct? 90 is cut in fourths, right? 360. And so then will this be 180 degrees? So this will be 270. Oops, right here. 270 degrees. And then we're back to 360. Okay. The next thing I do is say, well, where does my right, like, what are my next angles? Well, where does the unit circle come from? It's special right triangles. So 30 degrees, 45 degrees, and 60 degrees. These are special right triangles. So I remember those easy. Now the next part you can memorize however you want, but I just want to show you a relationship I'm seeing happen here. We went up 30, we added, from 0 we added 30, add 15, add 15, add 30. Yeah. Add 30, add 15, add 15, add 30. Add 30, add 15, add 15, add 30. So I just go through and fill that in like that. Does everybody see? So add 30, is everybody good? Add 15, 135, add 15. Is everybody seeing my little trick? And then add 30. Add 30, add 15, add 15, add 30. Add 30, add 15, add 15, and add 30, and I'm back to here. So now I filled in all my angles. Now I go through, and the first quadrant, I do kind of start out by actually converting these. So we're going to want to write these in radians as well, not in degrees, but in radians. So remember, I do it like this, the first one. 30 degrees, which you'll get this memorized pretty quick. We want to go from degrees to radians, so remember you multiply by pi over 180. So you'll type into your calculator 30 divided by 180, math, enter, enter, you get 1/6. So that's pi 6. Then I do that with 45 times pi over 180, and then I get pi fourths. And I do that same thing with 60, and I get pi thirds. Now from here you could keep going. Well, we know a couple other special ones. This will be 2 pi, correct? Yeah. Or 0. Very good. 0 radians or 2 pi radians. This is cut into fourths, correct? Right here. So won't this be pi halves? Yeah. So look, 1 pi halves and then 2 pi halves is pi, correct? 3 pi halves. And then 4 pi halves puts us back in the right spot. So I always look at my algebra. Oh, that is 2 pi, so we're golden. Now, I filled in these, and so you can go through and keep converting these like we did with these, or you could do, like, look at my trick. This is how I like to do it. So, remember, a radian is the physical distance, correct, everybody? Yeah. So, look at this distance from here to here. That was 1 pi 6. So, another amount of that distance would be 2 pi 6, which simplifies to be pi thirds, right? Another amount of that distance would be 3 pi 6. 3 pi 6, which is pi halves. So then where will that distance put us at? 4 pi 6, which simplifies to be 2 pi thirds, right? Then go that distance again, and that would be 5 pi 6. That distance again would put us at 6 pi 6 right here, which is pi. Then right here, that distance again is 7 pi 6. Then from here to here would be 8 pi 6, which is 4 pi thirds. And then this is 9 pi 6, which we have as 3 pi halves, so we're doing good. Then right here to here would put us at 10 pi 6, which is 5 pi thirds. Then right here would put us at 11 pi 6. And then look, make sure you end up right. This is 12 pi 6, which is 2 pi. Does everybody see my trick? Or you could convert, so if you were ever unsure, just take 330 divided by 180, math, enter, enter. Whatever you think's easiest. And then I do the same thing with my pi fourths. From this distance to this distance was 1 pi fourths, so that distance again right here to here would be 2 pi fourths. That distance again would put us at 3 pi fourths. 4 pi fourths, 5 pi fourths, 6 pi fourths, and 7 pi fourths. However you want to do it, or you could just convert them using your calculator. Math interesting. You know what I mean? But that's just a trick I use. Now this next part is the best trick to watch. You don't want to have to go through and do the algebra every time to figure out those XY points, correct? Now that we know where they come from, I just use this little trick that I have. It might not be the same trick you want to use, but it's actually pretty simple. So I just focus on quadrant 1 and I start from 0. Since you know where these come from, this is not technically where these come from, but this is just a little trick I use. So I start with my zeros and go backwards. So I just say this is the square root of 0 over 2. Then I count up square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and then that's square root of 4 over 2. Which the square root of 4 over 2 is, watch, what's 4 over 2? Square root of 4 over 2. Isn't that 2 over 2? Which is 1. So we're good? And then look, square root of 1 over 2 is just 1/2, correct? Okay, so now I'm going to do that the other side. 0, so this will be the square root of 1 over 2, which is 1/2. This is the square root of 2 over 2, square root of 3 over 2, and then square root of 4 over 2 would be 1. And now that I know quadrant 1, I can fill in the rest. Yeah, perfect. So we'll go in and add in the correct signage for these XY points in a second. So once you know quadrant 1, you know the rest of the quadrant. So look, this is up 30 degrees, this is up 30 degrees. So this will be that same point, square root of 3 over 2 and 1/2. Then this is up 45 degrees up here, so is that. So this will be square root of 2 over 2, square root of 2 over 2. And then this is up 60 degrees, up 60, so this will be the same point, square root of 3 over 2. Now all you would change is say, now this is in quadrant 2, so these are negative x's, positive y's to get up here at those points, correct? Negative x, positive y, so just go and change your x's to be negatives. So, once again, since we know our first quadrant, we can go in and fill this. This is down 30 degrees, so it'll be the same as the up 30 degrees. Square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, and this is 1/2, and square root of 3 over 2. Now you'd say to yourself, these xy points are positive x, negative y's, right? So negative y's, just change your y's to be negative. And then over here, this is down 30 degrees, so it'll be the same as up 30 degrees. So square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, and then 1/2, and square root of 3 over 2. Now you'd say these are xy points that are in quadrant 4, negative x, negative y's. And now we filled out the whole unit circle, and now we can answer when I say find sine of 180 degrees. You just locate 180 degrees, sine is y. You see how easy it is? Find cosine of 135 degrees. You'll find 135 degrees, cosine x, you'd say negative square root of 2 over 2. So it makes it really easy to evaluate exact values for certain angles. Okay, I'm going to give you a second. Grab a blank unit circle off your desk and see if you can fill it in without using any notes or any help. So, quiz next time. Remember that these are actually written out in pi radians, but we could actually find the actual radians. So remember that a full circle is 2 pi radians, which means there's about 6.2 radians in a full circle, right? So now, if I actually took my calculator and typed in pi divided by 6, that's 0.52 radians. And if I type in pi divided by 4, that's 0.78 radians at that point. Does that make sense? It's been 0.7, that's up 0.78 radians. Does everybody get what I'm saying? Like physical distance-wise? So like if I kept doing that, like I'm just going to do a couple more, like if you do in your calculator pi divided by 2, you get about 1.6. That's about in distance 1.6 radians. And if I keep doing this, this would be like 2.09 radians. This is about, right here is about 2.6. If I type into my calculator 5 times pi divided by 6, and then this is 3.14 radians. This is 3.7 radians. This is 3.9 radians. This is 4.2 radians. This is 4.7 radians, and so on. This is 5.2, 5.5 radians, and 5.8. So if I said to you, what quadrant does 3.8 radians fall? Yeah, right in between these two, correct? So do you see how that might be helpful? What quadrant would 3.8 radians fall in? You'd say quadrant 3. Everybody see how the radians might be helpful in a sense. The actual distance. Okay. Cool. So just a thing to remember. Okay, so now let's use your unit circle. So come for the quiz ready. Let's actually do that and evaluate the 6 trig functions. I'll give you just these 2 examples and then you'll get it. And we'll move on. So everybody, find sine, cosine, tangent, cosecant, secant, cotangent of pi 6. So we're going theta of pi, which theta is pi 6. So locate pi 6 on your unit circle. I'm going to change color. I do not like that. Pi 6, find it. We're looking at these xy points. Everybody good? So now watch how quick it is, instead of using right triangle trig, to use our unit circle to find the exact value. So when it says find sine of theta, if theta is pi 6, we're really finding sine of pi 6. Does everybody understand? So sine of pi 6, remember that sine is our y value, correct? Everybody? So 1/2? Everybody understand? So what's cosine of pi 6? Well, cosine is just the x value, so square root of 3 over 2 is our exact answer. Tangent is cosine divided, or y over x. So that would be 1/2 divided by square root of 3 over 2. So we flip the second and multiply, right? 2 over square root of 3. So that would be the square root of 3 over 3. Am I right? Cosecant. The 2's will divide out. Good question. Cosecant is the reciprocal of sine, so that'd be 2 over 1, which is 2. Secant would be the reciprocal of that, so that's 2 over the square root of 3, which simplifies to be 2 square roots of 3 over 3. We would rationalize the denominator. And then cotangent would be the reciprocal of tangent, right? So we just do that. 3 over the root of 3, which would rationalize to be 3 roots of 3 over 3, which would be the root of 3, correct? Everybody? Okay, let's do this last one, and I'm doing it for a reason, so everybody watch. So what is, oops, I just erased sine, huh? Sine. So sine is 0. We're talking that xy point. I'm going to highlight it. So 0, 1. Okay, so sine of 0 is, sine is, cosine of theta is 1. Tangent is 0 over 1, right? 0 over 1, which is 0. Cosecant is the reciprocal of sine. Technically 0 is 0 divided by 1. So 1 over 0, can we divide by 0? So we say undefined. Secant is technically 1 over 1, so we would flip. Cosine is 1 over 1, so secant is 1 over 1, which is 1. Cotangent would be 0 over 1, which would be 1 over 0, which is undefined. Everybody good with using the unit circle? Pretty simple, right? Cool. Great, we won't do those ones then. Okay, it says, what is the sign? So now let's see if you could do something worded differently. This is one I have seen on an end level test. I've also seen ones very similar on our but I say the ACT or end level, because I've seen them on both. Here we go. So it says, what is the sign of negative 15 pi thirds? Well, isn't that the same thing as saying, what's the sign of negative 5 pi? Which we could go through and figure out where the negative 5 pi is, or can we just find the coterminal angle? Coterminal of that. So think about it. I like to look at positives, so I'm going to add 2 pi, add 2 pi. That still would be negative, right? Add 2 pi and we get pi. So negative 5 pi will be in the same place as pi. So I locate pi, there it is. So now let's answer it. What is the sign of pi? Go to pi, what sign? 0. Our answer is 0. It's that easy. Beautiful, right? Hey, what's the cosine of negative 90 degrees? Negative 90 is not bad. It's right there. So answer it quickly. What's the cosine of negative 90 degrees? 0. What is the sign of 225? Locate 225. What's my answer? Sign is negative root 2 over 2, which is the y value. Does everybody see how easy this makes this? Awesome. Okay. Questions on any of that? Okay, we're getting down to the nitty gritty. Okay, last few things. The ones on your homework will be that easy. So let's talk about domain, and then we're not going to really get into period. You won't even see that word on the test or on the review or anything, but we'll just talk about what they're talking about in the book. Okay, so domain is, for this unit circle, what are our possible domain? Like, what do our x values bounce between? Well, if this is a circle with radius 1, then isn't this value 1, this x value 1, and this x value is negative 1. So isn't our domain bouncing between negative 1 and 1? Now, if you go through and look at all these x points, these x values on all of these xy points, you'll see that all of those values, if you actually calculate them, will bounce between negative 1 and 1. So we would say our x values are greater than or equal to negative 1, but less than or equal to 1 on the unit circle. Now, you would see it probably is, so if that's true, then we know that cosine is x, so our cosine of our angles will be between negative 1 and 1. That would be our domain. Our cosine is our x values, so we're saying all our x values, which are our cosine values will be between negative 1 and 1. Now our range is the possible y values. Now range is y values like I just said. So this is up 1 and this is down 1. So if you were to look at all these y values and actually calculate them, you'll see all of them are between negative 1 and 1 in value. So we would say negative 1, y is greater than or equal to negative 1, but less than or equal to 1. So if that's true, then all of our sine values, because sine is y, will be between negative 1 and 1. Everybody feeling good about this? Now in your book, you're going to see this. They say use the period to evaluate trig functions easier. So do you see how in that last example, in 2 examples ago, instead of looking at negative 5 pi, I chose to look at pi because it's the same thing? That's what they're doing here, and I'll make sense of it. So what you'll see in your book is this. They say sine of theta equals sine of theta plus 2 pi n, where n is the number of times you add 2 pi. So if that's true, and cosine of theta will equal cosine of theta plus 2 pi n. Now I'm going to make sense of that for you. If you want to write that down, I'm going to make sense of it for you. But if you understand coterminal angles, it will make sense. So everybody watch. Okay. Let's say I am looking at 45 degrees here. The sine of 45 degrees. What is the sine of 45 degrees? That value, correct? Now think about it. If I take 45 degrees and I add 2 pi, isn't that sine value going to be the same thing? Yeah. Now if I add 2 pi again, won't that still be that sine value? Yeah. So I can add 2 pi as many times as I want, and my value will be the same as the original. Does everybody see? My sine value, that x value, that y value will always be the same. Everybody good with why that formula makes sense? That's all that's saying. So you're just using coterminal angles. Same with cosine. Okay, so number 30 in the book. This is an example of that. It says, use the period, and this isn't on your assignment. I'm showing you, though, just what this is making sense of this for you. So when you get to your homework and read the instructions, you're not like, what is this talking about? So this is number 30 in the book. The instructions say, use a period to easily evaluate what this value is. So it says find cosine of 5 pi. So basically, we would say, okay, 5 pi is where? Well, we're just finding coterminal angles. So take 5 pi, subtract 2 pi. What would that be? 3 pi, still not there. Let's subtract 2 pi again, and we get pi. So cosine of 5 pi will be equal to cosine of pi, right? Is that true? So go to pi, ding, ding, ding. What's cosine of pi? Negative 1. That's our answer. So it's basically just using coterminal angles. Okay, now last but not least, this is last but not least. Here we go. So remember back, you'll want to take some notes. Remember back to the first 2 weeks of school. I can still remember it like yesterday. And we learned about even and odd functions and how to algebraically go through and figure out if something is even or odd. We did learn that. We tested on it on the first test, and a lot of people didn't get it right. So hopefully it will make more sense today again. So, even functions and odd functions. So I'm going to re-explain it, and then I really had so many people go, oh my gosh, that makes total sense, and it never made sense until now. Hey, everybody, you know a function is considered even if you have the original function, you plug in negative x, you plug in a negative x, you simplify it and get out the same function. If you plug in negative x and you simplify it and get out the original function, f of x, so if you started with f of x, you plug in a negative and you get out the original function, the same thing, then it's considered an even function. So I write that down again for myself. And then an odd function is if you take an original function, you plug in negative x, you simplify it and get -1 times the original function f of x, then it's considered odd. So if you don't get the same thing but you get -1 times the original function, it's considered odd. So even functions, just write this down. Cosine is considered an even function. In a second I'll show you why. And that's when you're going to go, oh my heck, that makes total sense. So cosine is an even function. Well, if cosine is even, then its reciprocal secant will also be considered an even function. So our odd functions are sine. So its reciprocal cosecant will be considered odd. Tangent is considered odd. So if tangent's odd, then cotangent would also be considered an odd function. I'm going to make sense of this so that if you ever forget, you could test and say, well, is sine even or odd? And then I might ask on the test, why is cosine even? Give me an example. So this is an example of why. So I'll let you write down that, and then I'm going to show you why. And I literally hope you go, oh, that makes total sense.